with this, it's a little bit bigger than the problems that we saw last time. But we'll see that it's just a matter of making zeros and ones. Now, like we saw on that last slide, the first thing I want to do is isolate the variable. So I want to get the variable by itself. The variable, in this case, is x. So what I would notice here is that I would like the x to be by itself. It is not by itself, and I'm not talking about the negative 5. That's negative 5x term. It's the plus 8 that I can't have there. Meaning, what I really want to be able to do is take that negative 5x, and I'd like to just be able to drop it down here. Like this. And then, once I do some kind of principle of equality here, it should just read negative 5x equals something. Well, that means that I can't have this plus 8 right there. And since it's an addition operation, addition and subtraction mean that we're going to zero it out, which also means that we can ignore it. So I will do that. I will take that plus 8 and subtract 8 in order to make a 0. But if I do it to one side, I must do it to the other side as well. Now, if I were to look at this, I see that I have dropped my negative 5x's. I now have 8 minus 8, which is 0. That was part of the plan. And then on the right side of the equal sign, I've got 33 minus 8, so I'll make that 13 minus 8, which is 5. And then the 2 will drop. So now I have an equation showing negative 5x equals 25. And that did isolate the x's, or it got the x's by themselves. All negative 5 of them. Now, it becomes like a problem like the starter problem, meaning that it's like if we had started with this problem right here, it kind of looks like the starter problem. But we had to do some work to get to this point, and that was okay. We just had to zero out a value. But now what I'm going to do is I'm going to make that coefficient of x a 1. So we'll make it a 1 by taking negative 5 coefficient and dividing it by itself. That's the division principle of equality, which is meant to make ones, which we just did. But if I do it to one side, I need to make sure I do it to the other side. So now, on the right side, 25 divided by negative 5. How many times does 5 go into? Well, I guess first I should say it's negative, because we have a negative and a positive. How many times does 5 go into 25? 5 times. Now, this negative 5 came from the division. It has nothing necessarily to do with this one. But that's pretty much it. Now, the last thing I'm going to do here is just check, right? So I'm going to go back to my original equation, negative 5x plus 8. And remember, that's supposed to be a solution. The 1x equals negative 5 should be a solution. So that means that negative 5x plus 8 needs to equal 33. Now, I don't know if it does if I take the x and if I were to replace it with negative 5. But I'm going to find out. So negative 5 times negative 5 is 25. Now I got 25 plus 8 equals 33. By the way, this 25 right here comes from this 25 right there. So it's kind of like we worked down through this, from this original equation, we worked down. Now we're going to work back down, or it's kind of like working our way back up. Depends on how you want to look at it. Well, 25 plus 8 is going to be 33, which does equal 33. At least last time I checked. That right there is true. Now we know we have found the solution. And it is a solution because it makes the original equation from here. Once we replace the x with negative 5, we did some math and found that the equal sign is a true statement.